What is context engineering? Context engineering focuses on designing systems that understand and respond to the context of data, users, and environments. It enables applications to make intelligent decisions based on situational awareness. The goal is to enhance personalization, automation, and relevance in digital experiences. What are the key components of context engineering? Data acquisition from sensors or digital sources, context modeling and interpretation, machine learning for predictive analysis, decision-making based on real-time context, feedback loops for continuous optimization. How does context engineering differ from traditional software engineering? Traditional software engineering builds fixed, logic-based systems, while context engineering builds adaptive systems that evolve with changing environments. It focuses on real-time decision-making using contextual data, unlike static rule-based architectures. What types of data are used in context engineering? User behavior data, clicks, searches, preferences. Environmental data, location, time, weather. Device data, battery, network, sensors. Historical data for trend analysis. System performance metrics. Why is context important in AI systems? Context helps AI systems interpret data meaningfully rather than mechanically. It ensures that responses are relevant to the situation. Without context, AI can misinterpret intent, leading to inaccurate or irrelevant outputs. What are some real-world applications of context engineering? Personalized recommendations on e-commerce sites, smart home automation systems, adaptive learning platforms in education, context-aware healthcare monitoring, intelligent transportation systems. How is machine learning used in context engineering? Machine learning in context engineering is used to analyze contextual data and identify hidden patterns. It helps systems predict user behavior and environmental changes in real time. ML models continuously learn from feedback to enhance decision accuracy. This enables adaptive, context-aware applications that evolve intelligently over time. What is a context model? A context model is a structured representation of information about users, environments, and systems. It defines how contextual data like location, time, or activity is captured and related. The model helps systems interpret real-world situations accurately. It serves as the foundation for making adaptive and intelligent decisions in context-aware applications. What are the main challenges in context engineering? Handling noisy or incomplete data, managing data privacy and security, real-time context updates and interpretation, system scalability and performance optimization, integration with existing infrastructure. How is context awareness achieved in IoT systems? IoT devices collect data from sensors, which is processed to derive contextual insights. These insights drive adaptive behaviors like temperature control or predictive maintenance. Middleware and edge computing help manage real-time context efficiently. What role does natural language processing, NLP, play in context engineering? Natural language processing, NLP, helps systems understand human language in the right context. It interprets meaning, intent, and emotions beyond just words. NLP enables context-aware applications like chatbots and voice assistants to respond naturally. By analyzing user input and environmental cues, it enhances personalization. Overall, NLP bridges the gap between human communication and machine understanding in context engineering. Explain the concept of context lifecycle. The context lifecycle includes stages like acquisition, modeling, reasoning, and dissemination. Each stage ensures the right contextual information is collected, interpreted, and applied effectively. This life cycle enables continuous learning and system adaptation. How do you ensure privacy in context-aware systems? Use data anonymization and encryption. Collect minimal necessary context data. Implement user consent and control mechanisms. Follow GDPR and data protection regulations. Regularly audit context data handling. What is context reasoning? Context reasoning is the process of deriving new insights or decisions from available contextual data. It uses rule-based logic, probabilistic models, or AI algorithms. This helps systems adapt intelligently without manual intervention. What are context-aware architectures? Context-aware architectures include layers for data sensing, processing, reasoning, and application. These layers work together to sense, analyze, and act upon contextual information. Examples include middleware-based architectures and agent-based architectures. How does context engineering enhance user experience? By adapting to user behavior, location, and preferences, context engineering creates personalized experiences. It reduces friction and increases engagement. For example, Netflix recommending content based on viewing time and history. What are context-aware APIs? Context-aware APIs provide interfaces for integrating contextual intelligence into apps. They allow developers to access real-time user context, device data, and environmental variables. Examples include Google Awareness API and IBM Watson Context APIs. How does edge computing support context engineering? Edge computing processes data closer to its source, reducing latency. This enables faster and more accurate contextual responses. It's vital for time-sensitive applications like autonomous vehicles and IoT-based monitoring. What is the difference between implicit and explicit context? Implicit context, automatically collected. Example, location, device data. Explicit context, provided by the user. Example, preferences, inputs. A good system balances both for personalization without invading privacy. How is context represented in a system? Context can be represented using ontologies for semantic relationships, key value pairs, or JSON structures, relational or graph-based models, knowledge bases for reasoning. What programming skills are useful in context engineering? Python and Java for back-end development, SQL and NoSQL for data management, AI/ML frameworks like TensorFlow or PyTorch, API integration and RESTful design, cloud computing and IoT frameworks. How does context improve decision-making in AI systems? Context improves decision-making in AI systems by adding situational awareness to data interpretation. It helps AI understand why and when certain actions are relevant, not just what to do. By considering factors like location, user intent, and environment, AI decisions become more accurate. This leads to personalized, efficient, and meaningful outcomes in real-world applications. What tools or platforms are used in context engineering? Apache Kafka for data streaming, AWS IoT Core and Azure IoT Hub, Google Contextual APIs, TensorFlow for predictive modeling, Apache Flink for real-time processing. How do you test a context-aware application? Simulate different environmental and user contexts. Validate data collection and reasoning accuracy. Test adaptability under real-time conditions. Verify performance under network variations. Check privacy and security compliance. What is the future of context engineering? The future lies in hyper-personalized, adaptive, and intelligent systems. Integration with agentic AI, IoT, and edge AI will drive context-driven automation. Context engineering will become the backbone of smart environments and autonomous decision-making.